contrast. Okay. Can you guys read it? Let me just check. Okay. Okay, I thought I'd talk about the view component system we use at Shopify, and specifically the open source implementation I published. So if you like, essentially the concept I'm going to present, you could just pull in the gem and use this concept yourself in your own Rails applications. Well, the library is called ActionWidgets, and I will go into why view components are actually important in our applications and what my definition of a view component actually is in the context of a web application. So I want to start with the why. And one reason is probably that views in Rails applications are generally the most neglected part. Sort of just a bunch of HTML we often don't really care about as Ruby developers because we rather tinker around with the backend code. And so views often end up having a lot of code duplication and not being as structured as our Rails code. And in general, code duplication seems to not concern us as much. But there's generally a more severe problem to the way we work with views in Rails applications, and that is that we often don't separate the concept and the representation of a view component. And I'll go into detail what I exactly mean by that in a few minutes. But this is generally the standard for desktop applications or mobile applications even if you think about it. In a Rails application you often end up duplicating chunks of HTML code to express a certain UI pattern, whereas in the desktop application or mobile application you usually have a class defining a particular component, for instance, such as a button. And if you look at how the UI, for instance, of the iPhone changed over the years, conceptually a button always remained the same thing, but the representation of a button drastically changed, I think, when we moved from iOS 7 to iOS 8, where they essentially became just text. So to give you an example, let's say we have this super simple panel which has a headline and some stats that it's displaying. If you would use Objective-C to sort of render this panel, and the code really is of no interest here. This is essentially the bunch of drawing code you would have to use to draw these pixels onto the screen of an iPhone. And you would probably agree that duplicating this code is a bad idea because it doesn't allow you to change the representation of the panel afterwards. If we look at HTML, it looks a lot better, but we often end up seeing chunks like this duplicated all over our application, and it still becomes problematic the moment we essentially want to change how a particular component is displayed, but not necessarily change the component's function. So in this case, a panel would always remain to be a panel, and as such it would be defined as something that has a title and displays statistics. But the way we structure our HTML, or the way we essentially connect our CSS to that HTML might change over time. If, for instance, our designers think of a redesign and a new concept, a new visual concept essentially for the component. But that shouldn't affect the underlying code. And in this case, we still very much mix representation and code, because we essentially use a language that is meant for expressing a visual representation or structure of a component, being HTML and CSS, with what the component essentially is. So at Shopify, we thought long about how we can efficiently separate these concepts in an easy and straightforward way. And one potential solution is ActionWidgets, which I'm going to demonstrate now. The idea behind ActionWidgets is that the concept of a UI component is expressed through its API definition. So by providing clean and concise definition of your API across all components, you essentially make it easy for everyone to use these components, because they function all in a similar way, and you make it very explicit on what your component requires to be actually displayed. And the underlying representation still remains just HTML, CSS, and JavaScript, so no real trickery going on. And the key gain is essentially that by separating these two things, you can change them independently. Although you have to take into account if you want to change the concept of a component, this can often result in a change in its visual representation as well. But if you want to change the visual representation, you can often get away without touching the interface of the component, meaning wherever your component is used in a template, you don't have to make any adjustments. To get back to the example with the panel widget, the widget definition using ActionWidgets looks as follows. You inherit from the ActionWidget base class, and then you have a set of properties describing the input of a component. In this case, we have two properties, the title and the type. And the type in this example is just that a panel can either be highlighted or regular. And the type has always to be set, and by default, it's being regular. So even if you omit it, it will just default to this value. But if you explicitly provide the type, it has to be one of the two values. And then the actual definition of the widget is in the render method, which in this case takes a block, which defines the widget content, and then it essentially takes care of wrapping the HTML around your content, so that you don't have to do this manually. To make this a little more understandable, the way you would call it is you have an automatically generated helper method that is simply your widget name underscored, and then you provide the properties. And what I omitted here, the widget would actually take a block that defines the content and is then rendered inside of this div essentially. And there's also, you can also always manually invoke a widget and put it on the slide so you better understand what's actually going on. What this helper method essentially does, it gets hold of your current view context, which is your action view instance. And the view context in the template is always referenced by self. And then you pass on the view context as the first argument, followed by the values for your properties. And then you would call render on this method and would get back your HTML. So the helper method is essentially just for your convenience and to make the interface essentially the same as arrays helper. The way it works is action widgets always delegate method calls to the view context. So all helper methods that are accessible in your template are also accessible in any widget. If you want to explicitly call methods on the view context you provided to the initializer, you can always do this by calling view explicitly. And then, as you've seen before, action widgets support properties, which are sort of a little more advanced Ruby attribute assessors. So the call to property actually generates an attribute assessor pair for you, and the call to converts specifies what should happen upon assignment of this attribute. So the moment you assign a value to title, either through the constructor or through the setter, the toS method will be called on this value. Alternatively, you can provide a block here to specify arbitrary complex conversions. Same with accepts. You can either specify an array of accepted values, or you can specify a lambda expression that specifies sort of an input validator. And then you can flag a property as required, meaning you can't omit it when you initialize a view component. That's sort of the simplest widget implementation possible. It renders nothing, but you always have to suffix a widget with widget in order to make use of the automatically generated helper methods. But it's actually configurable, so you can either decide to set a custom prefix or suffix or just nothing at all, and the helper methods will be generated accordingly. And then one of the most powerful features of, and reason why you want to use widgets and extract your view definition into an entire class as opposed to a single helper method is that you can make use of standard refactoring techniques. You can extract code from your render method in private helper methods. You can combine methods that you use across several widgets in either a common superclass or a module, and essentially also try to make the widget code more readable and more understandable what is going on. And yeah, I was asked once why we shouldn't just use partials, and one of the reasons is that by using a class you have an explicit interface definition through your properties, and these by specifying exactly what these properties accept and whether they are required, you also get imminent feedback if you sort of misuse a component. And one of the main reasons is that by using ActionWidgets you get a unified and consistent interface that you can sort of simply grasp by looking at your widget definition, as opposed to going into the partial file and then figuring out which local variables it depends on. And theoretically, a widget, you can also use reflection mechanisms to determine what properties a widget actually requires, which you couldn't do with a partial. As I just mentioned, the explicit definition of an interface is something I find very valuable because it makes it easier for new developers to immediately see how the component is being used. By using accepts box and flagging properties as required, you enforce constraints, meaning you don't accidentally ship broken HTML that then is usually first discovered by a customer, notifying support, eventually notifying you as a developer. Instead, you actually get exceptions if you, for instance, omit the title or the caption on a button, meaning you have imminent feedback in your development cycle. And of course, you can blow up production if you actually have view code that isn't covered by any tests, and you're using a restrictive component. That can result in 500, which we had at Shopify once, but yeah, there was a debate essentially going on whether we want to accidentally ship broken code and then have a much longer cycle of actual customers notifying support that our UI doesn't look as it's probably supposed to look, or having essentially our exception notification system catch the error and then notify us immediately. And by now we're actually using a mechanism where components have a fallback, meaning instead of preventing the entire site from rendering, we define certain components as non-crucial, and if a non-crucial component doesn't render, a placeholder is rendered, which is usually just an empty string, but our exception notification system gets triggered and notifies us immediately that a particular site is not rendering as it's supposed to render. Yeah, and that again caters to the immediate feedback. I already mentioned you can make use of any object-oriented design principles to build these components. You can use inheritance modules, can structure your code as readable as possible. And you can test these few components in isolation. It's actually really easy to write UI component tests where you essentially test that component outputs the current HTML, meaning you have to write less controller tests because most of the time you only have to make sure that these controllers use certain components and then don't have to write as many tests as before. I'm going to show you some more examples on more advanced widget definitions. So the code you see here is actually rendering this slide. So the entire slideshow, as well as the one I presented at RubyConf, they are based on middleman and use ActionWidgets. And the way I implement it is I have a slideshow widget which gets passed into the block, and then I can call on my slideshow widget the slide method, which generates one particular slide, and then the slide itself takes the content. This is some of the code of the slideshow widget. The crucial part is the way this block gets processed. So essentially, this block here, which is passed into the slideshow widget, is assigned to this variable, and then I use the Rails helper capture, which allows me to render a block by also passing in an arbitrary variable. And what I do here is I pass myself in, meaning the widget, and in the widget I define public helper methods, such as a convenient method to render another widget, in this case a single slide. And then the slide itself is widget. So you can arbitrarily nest them, you can define as many public helper methods in your particular widget class, and then just make sure that if you capture the block that is provided from your template, that you pass in yourself, so you can make use of these helpers that are defined in this widget. And then I have a bunch of helpers that essentially, for instance, the green slides that you see, they are called stages. So I have a bunch of helper methods essentially in my slide that make expressing the entire slideshow as code extremely readable and yeah, as little as code as possible. And here's, for instance, one that just that can be used to center content on the slide. And yeah, that's essentially. Then I have these stage slides, which render the green slides, which essentially all they do is they assign a particular CSS class, which does all the styling, and then they center all the content that you essentially provide to the slide. And the way you would invoke the slideshow is, yeah, what you call the slideshow widget, and then you can use your helper method, and this would be the result as output. Yeah, to summarize, ActionWidgets provide a lightweight and consistent way to define interface components for Ruby Rails, and all the code I've presented here is essentially available as open source projects. Thank you. Any questions?
Can you just go back to the one where there's a slideshow widget, the first one, and then there's the one with the slide widget. And I was just reading the code. So going back to the last one, to the review. So basically, I'm just repeating what I read. Right? So slideshow, we have a slideshow, and then within the slideshow now we can call the slide and then call stage.
Yes.
And then stage is the one that centers the
yes. So all you essentially do is you can define arbitrary helper methods in your widget definition, and then as soon as you pass the widget to the block can make use of all these helpers. So if I go back one more slide, well, self in this context refers to my slideshow, and then show refers to this particular instance of the widget.
So the widget itself doesn't have its own markup, right? Like it's not surrounded by a div that's slideshow dash widget or anything like that. You have to define everything yourself in render.
Yes, but I usually have a custom base class I use, which does project specific wrapping. We have naming conventions on how our CSS classes are generated. So we have a high-level widget class that does enforce all these patterns we essentially agree on. But I didn't want to implement that as part of the open source project, so everyone has all the flexibility they essentially need to implement them in whatever way they want. And there is also extensive README on the project page. So if you want to use that, is essentially I cover everything from defining simple widgets such as buttons to these more advanced nested components, and showcase how that works.
Yes. Can we look at an example of how to test an ActionWidget, like test code for because I've tried making a view component, but I had problems with like mocking the view context.
Okay, yes we can. UI component in Shopify. We have a helper method for rendering ERB. And then, yeah, well, we just call the UI avatar helper method, which is generated by the UI avatar class, and provided with the expected properties. So an avatar always has an image in our case. It has a title and a subtitle. In this case, this avatar refers to maneuver driver. And then you can use the assert select method provided by Rails to sort of assert that the generated HTML is according to your specification. Yes?
How does it perform when compared to more conventional implementations like Rails? Do the additional functionalities like conversion and validation added overhead to the render function?
Yes, they do. But almost any request by now served at Shopify uses UI components in one or more ways. So it is not a huge overhead. Don't ask me for numbers. I can't.
So I think you mentioned a bit about CSS. So say you want to create, I don't know, a credit card widget, credit card input widget. So you're going to need images, you're going to need CSS, you're going to need probably JavaScript also to handle the validation and all that. How do you do that in ActionWidget?
Okay, the way we do it is we have a corresponding CSS file that is also named after the widget. So we have a UI avatar SCSS file. I think it would be a bad idea to sort of inline the CSS code into the widget class. So we just follow what you would generally do in a Rails application. As for JavaScript, it highly depends. We either have again a UI avatar JS file, but we also have
Inline JavaScript.
yes. Essentially, we have our content 4 elements sitting at the end of the page, which allows us to render JavaScript in this particular place. And in this case, what we are rendering here is a time series graph for our admin dashboard, meaning we have a bunch of data we want to directly inject into the JavaScript, which is why we actually render JavaScript inline here. And the way JavaScript works is well, this is the base class that I was talking about. All it does is
Looks familiar.
it takes the JavaScript and outputs it to the content 4 tag.
Yeah. So yeah, I actually made the widget component in a credit card form, and that complicated. It took me, I think, a week to do that in another framework.
Any more questions?
How do you cache? Do you put the cache code in the view file document?
Highly depends on what you are doing. You could theoretically use the Rails caching mechanisms right within your components. What you could probably do is there's another level of indirection, which you see here. What happens when a component gets rendered is that you actually call the class method render, and then This one instantiates the component and then calls the instance method. So if you want to provide caching for an entire component based on sort of the attributes, for instance, you would override this method and just grab the entire thing into a cache call. So there's a couple of methods to hook in. The reason why the convenience method exists is by default, all components expect keyword arguments, but let's say you want to provide the data that is being rendered here as a positional argument because it makes sense that a time series graph accepts an array of data, and only provide the remaining properties as keyword arguments, then you sort of redefine the interface that your component accepts by overriding the class method, and then still making sure that from there on to the constructor, all properties are passed on as a keyword argument. But that would also be the perfect place to wrap the entire thing into your cache call.
So there's a nested, there are nested components, and then like the last smallest component, you change that, you have to bump the cache manually, like the Russian cache.
Yes, there is currently no mechanism provided by ActionWidgets that would sort of implement caching. If there aren't any more questions, thanks again.